This short video covers how we define and refer to different types of variables. It's important to understand this as it forms part of the everyday language of statistics, and also, as you'll see during the course, the way in which data are summarised and analysed is strongly determined by the type of variable that it is. So here's a subset of data from an observational study. In this particular analysis, we were interested in the link between maternal vitamin D during pregnancy and the birth weight of the offspring. So this is typically the format that data are organised into for analyses. We call it the raw data or the data matrix. The data are organised into rows and columns. Each column is a variable and each row represents a unit of observation. In the dataset here, the unit of observation is the mother and offspring pair. Birth weight relates to the child, and all the other data relate to the mother. And you can see by looking at the values in the data matrix that some of these variables are inherently different. So let's define them. So child's birth weight and maternal vitamin D are both numerical variables and are on a continuous scale. By continuous, we mean that in principle, they could take any value within a biologically plausible range, of course. Maternal parity is slightly different. On the other hand, it's also numeric, but it's derived from a count and so has a discrete scale, taking only integer values 0, 1, 2, 3, etc. So count type variables we call discrete variables. Maternal smoking, as displayed in this dataset, is a categorical variable. It has a natural ordering or rank, so we refer to it as a categorical ordinal variable, or just an ordinal variable. Socioeconomic position is also an ordinal variable. Sex and ethnicity are both categorical variables, but they have no natural ordering or no natural ranking, so we refer to these as nominal variables. It's also worth mentioning that a special case of the unordered categorical variable is one which classes observations into only two groups. Such variables are more commonly referred to as dichotomous or binary variables. So as an example, the presence or absence of disease, smokers or non-smokers, or people who like statistics and people who don't like statistics. So we can put this classification into a hierarchy, and it's worth ensuring you're familiar with and understand these terms, as an understanding of them will be assumed throughout the course. You may also hear the word derived to describe a variable. This is something different to what we've just been talking about. For example, here we have classified babies according to their birth weight. Those less than 2,500 grams have been coded as a 1 to indicate a low birth weight. So this new variable is said to be derived. In this case, we've used a cutoff or threshold to derive the new variable. Other types of derived variables we will discuss in more detail include transformations, such as log transformations and standardized scores. A separate way of defining a variable is in terms of how it relates to the study hypothesis or objective. For example, using the same data set, if our research question was whether maternal levels of vitamin D during pregnancy affect birth weight, then our outcome, or the variable we're interested in explaining, is birth weight, and our exposure, or the variable we think affects the outcome, is maternal levels of vitamin D. This should be self-explanatory if you consider how we might summarise the result of such a study. For example, babies that were exposed to higher levels of vitamin D in utero were on average born heavier. The terms outcome and exposure are frequently used in epidemiological studies, and in particular observational type studies where there is no experimental manipulation of the exposure, i.e. we just observe the exposure. So in this example, the exposure is vitamin D and we just observe that in a sample of the population. Other disciplines tend to have their own terminology, although they mean essentially the same thing, and in most cases terms can be used interchangeably with no loss of meaning. So here's a table of alternative terms, and you should familiarise yourself with these as they will be used interchangeably as we progress through the course. So to finish, here's a list of new terms we've introduced and defined in this video.